Good afternoon. My name is John Maisel. I am the publisher of Electrical Contractor magazine in Bethesda, Maryland. On behalf of the magazine, on our sponsor, which is Siemens Industry, and frankly, the rest of NECA and the industry itself, I just want to thank you all for your interest in today's subject. We're pleased to announce we've got over 780 people who have registered, which tends to lead that this is a pretty hot subject, because we want to thank you on behalf of the industry again. We also want to offer one more time our sincere thanks and appreciation to Siemens Industry, who have made as official sponsor, has made this session possible. And it's an important area. NFPA 70E changes for 2012. We all know that working safely around electricity is simply one of the most important aspects of any kind of electrical work. And NFPA 70E is the standard and intends to safeguard employees during installation, inspection, or operation of equipment. The 2012 edition is about to be released, and in order to help all of us better understand what's happening, we have two presenters today who can offer expert opinion, both from the standpoint of vast experience in the industry overall, and also vast experience from the manufacturer's point of view or the supplier's point of view. Our first presenter is Jim Phillips. And Jim Phillips, who is a PE, he's actually the founder of www.brainfiller.com and also arcflashforum.com. His career spans over 30 years. He has successfully conducted over 2,000 live electrical training seminars for literally tens of thousands of people for the U.S. and essentially all 7 continents. He's a member of the IEEE 1584 Committee, IEEE Guide for Performing Arc Flash Hazard Calculations, co-chairman of IEEE 1584.1, which is, most of you know, is the guide for specifying arc flash studies. Also ASTM F18, Electrical Protective Equipment for Workers. He's developed over 25 training programs on a wide range of topics about electrical power systems. He also wrote the book called Complete Guide to Arc Flash Hazard Calculation Studies. And Jim is a regular contributor to Electrical Contractor magazine. Our second presenter is Allan Worthy, and Allan is Senior Product Manager for Low Voltage Switchgear and Rear Connected Switchboards for Siemens Industry, Inc., based out of Atlanta. Allan's career spans over 20 years with Siemens and over 30 years in low voltage distribution equipment in the industry. He is an engineer, has worked as a design engineer, manufacturing manager, and application engineering manager. So we've got a lot of experience to help you better understand. And with that brief introduction, I would like to introduce our first presenter, and that's Jim Phillips. Jim, you got it.
Thank you very much, John. It's a great pleasure to be here at the offices of Electrical Contractor magazine in Bethesda today. And I'd like to thank everyone for joining in. This is a classic case that just about the time you think you have learned the rules from the 2009 edition, they change. And the 2012 edition is very quickly upon us. This revision cycle, the 2011 revision cycle, there were 548 proposals. Of these, there were 540 that were submitted from the public, and there were an additional 8 proposals from the 70E committee. The first place I'd like to begin is just with a change in terminology. Beginning with the 2012 edition, NFPA 70E is going to be changing the word flame resistant, FR, and begin using the terminology arc rated, or AR. And this is really just to be consistent with ASTM standards, because what you have is arc rated material. It is flame resistant, but flame resistant material is not necessarily arc rated. So that's a change that's going to keep us consistent with ASTM. Another change that has occurred is the applicability of the standard. It's for activities such as installation, operation, and maintenance, but this time around, the term inspection, the word inspection, has been added as well. So for those that perform inspection on electrical systems, this is to make sure that it's understood this document applies to them as well. Another change deals with electric utility companies. The applicability is with electric utilities if they have office buildings, warehouses, garages, machine shops, recreational buildings that previously it said that are not an integral part of a generating station or substation or control center. Well, that's being deleted. And now it's going to be just left with if you have office buildings, warehouses, garages that are part of an electric utility, this applies to them as well. That seemingly exemption wording is being eliminated. Informational notes, this is being changed to be consistent with other NFPA documents. In the past, there were notes that were referred to as fine print notes, and these are now being referred to as informational notes. They provide additional or explanatory material. NFPA 70E is providing us with a definition of incident energy analysis. This is new for 2012. And the definition, according to NFPA 70E, it's a method to predict incident energy from an arc flash for specific conditions. Now, there's a lot that actually goes into this. I know many of you are involved in arc flash studies, arc flash calculation studies, and the studies typically involve some pretty extensive calculations. Fortunately, there are a lot of good software packages out there that help along, but it can still be quite a complex undertaking. Knowing how to model the system, knowing what conditions that you need to model. And so we now have a definition that helps it along. And the real scope of an arc flash study, the fundamentals of it, is number one, you want to calculate the incident energy, and that's what a lot of the software will do. If there's an arc flash, how much energy may be available. And then you compare this to the arc rating of your protective equipment. And so that's the general scope. Now, the incident energy, there's a lot that goes into the incident energy. You need to factor in things such as intensity. Now, intensity is not, I'll say, an official term, but it's a term that I've used a lot. It's really the short circuit current. The higher the short circuit current, the more intense the arc flash can become, but it's also dependent on duration. And when you're looking at strictly incident energy, you can have a lot of short circuit current over a short duration, or maybe a lower short circuit current over a long duration, and for now, you'll have the same amount of incident energy. But a more intense arc flash, well, that's what can lead to the problem with explosive forces. The distance, it's also going to be dependent on the distance from the prospective arc, and also the equipment type. And the equipment type has a lot to do with it. If you have an arc flash out of a panel board, for example, versus arc flash out of switchgear, they behave a little bit differently. In the equations are something known, the IEEE equation, something known as an X-distance factor, and that just is a way to predict if you have an arc flash in a panel, it comes out a certain distance, and if you have it within a switchgear, it comes out a little bit harder, and standing at the same distance, you may have different incident energy. So the equipment type is very important in this as well. And the arc rating, part of the incident energy analysis, it's going to be the lesser of the ATPV rating, or the break-open threshold. That's according to ASTM. The arc rating is required to be on the garment label. And for now, the way that we do this, arc ratings are based on calories per square centimeter. I do a lot of work with European standards and actually spend a lot of time in Europe, and they keep bringing up the fact that they would like to be metric, joules per square centimeter. Calories per square centimeter is, well, we'll call it half metric. And they've even discussed going to kilojoules per square meter, which is the true SI unit. But that would cause, I think, quite a few problems. So we're going to stick with calories per square centimeter. The arc flash boundary has changed, the terminology again. This was arc flash protection boundary back in 2009. But there was a proposal that recognized that you have the limited approach boundary, the restricted approach boundary, and the prohibited approach boundary. And in all those other boundaries, they don't use the word protection. And so beginning in 2012, the word protection is going to be removed, and it's just going to be the arc flash boundary. So if you've followed this over the years, some of the evolution in 2004, this was called the flash protection boundary. And then in 2009, it became the arc flash protection boundary, and now in 2012, it's going to be the arc flash boundary. There's new language also about documentation between the host employer and the contractor. And what's required now is you have to have written documentation of a meeting that takes place between the contract employer and the host employer, and that's new. NFPA 70E has had requirements in there about training for CPR, but beginning in 2012, this is also going to be expanded to cover the defibrillators, the AED, automatic external defibrillators. That's going to be new in 2012 as well. There's also some new language about compliance with NFPA 70E, and the new language states that the employer has to determine through, and this is the way they can do it, regular supervision and through inspections that have to be held at least on an annual basis, at least once a year. And this is to ensure that the employee is complying with the safety-related work practices of this standard. And all this does is this mirrors similar language that's found within OSHA. We also have new requirements that retraining is going to be necessary, retraining to follow a period of no more than 3 years, and this is also going to be new within the 2012 edition of NFPA 70E. The training content has to be documented, so when people go through electrical safety training, the actual content of the training is required to be documented, so there's a, we'll call it a paper trail, of exactly what the participants were learning. And another change, the electrical safety program. The electrical safety program has been applicable anytime someone's within the limited approach boundary, but now in 2012, it's the limited approach boundary and or the arc flash boundary. Really, it's whichever one is going to be greater. And here's the problem that this is actually going to be solving. I have a, we'll say a representative panel on the right side of the screen. And up until now, this was applicable when people are within inside the limited approach boundary, and unqualified people were supposed to stay beyond the limited approach boundary. And that's fine as long as if you had an arc flash, it was a low enough magnitude of energy that the arc flash didn't reach the limited approach boundary. But the problem that you have, and this is this new article or this new language is clearing this up, is if the arc flash happens to be a significant arc flash with a significant amount of incident energy, it's possible, and in fact this does happen, that the arc flash can go past the limited approach boundary, and then the arc flash boundary is actually further back. And so you want to make sure that you're behind whichever one is the greater. Otherwise, in this case that I have up on the screen, if unprotected people were outside the limited approach boundary and this event occurred, it would be the proverbial bad day. The risk evaluation, there's also been a change here where this not only applies with the limited approach boundary, but the arc flash boundary has been included within this one as well. Lockout tagout has changed. Up through the 2009 edition, lockout tagout forms of control, there were originally 3 forms of control. You can have individual employee control, and this was for minor work, or you can have a simple lockout tagout, or you can have a complex lockout tagout for shift changes and things like that. Well, beginning in 2012, the individual employee control, that's being eliminated. So you're left with either simple lockout tagout or complex lockout tagout. There was a bit of a change in numbering with 130.1. The original 130.1 in the 2009 edition, this has been renumbered as 130.2, and we have a new 130.1 that states that if someone is using the hazard risk category tables, that all of the other requirements still apply. This is just enforcing that just because you're using tables, everything else is still going to be relevant, still going to be important in all of this. The electrically safe working condition, the arc flash boundary has entered into this as well. And with this, it's always been applicable if you're working within the limited approach boundary, but now the arc flash boundary has also been included, and also interaction. In the 2009 edition, there was language about an arc flash hazard could exist if there's interaction with equipment that could possibly create an arc flash hazard. And in fact, this new language in this section refers back to the definition of the arc flash hazard. Energized work permit requirements now also are going to include the term arc flash boundary. That if someone is working within the limited approach boundary or the arc flash boundary, the requirements of the energized work permit are going to come into play. The shock protection boundaries, we have a few new additions, actually quite a few new additions in this one. The original shock protection boundary table has been renumbered. It's going to be 130.4C1, and there's a new table, 130.4C2, that's being introduced, and this new table is for DC shock protection. DC is making its way into NFPA 70E, and I'm going to talk more about DC later on, but this new table is going to have, much like the AC table, a limited approach boundary and a restricted approach boundary and a prohibited approach boundary. And just an excerpt of the table, very small excerpt, because you really you want to get a copy of the 2012 NFPA 70E. It has everything that you need in there, but just a small excerpt for illustration purposes. The DC table, it lists by voltage, and then we have limited approach boundaries for the exposed movable conductor and exposed fixed circuit part. That's similar to its AC counterpart. We have the restricted approach boundaries, and we have the prohibited approach boundaries. So like we do with the AC table, you look up your DC equipment based on voltage, and you can locate the limited, restricted, and prohibited approach boundaries accordingly. The 125 kVA transformer exception, as many people call it, this has caused a lot of discussion. Formerly, Section 130.3 had an exception that said with this exception that circuits rated 240 volts or less supplied by one transformer with that transformer rated less than 125 kVA, you did not have to perform an arc flash hazard analysis. And what happened, this was actually language that was originally in the IEEE 1584 standard, and in IEEE 1584 it's less than 240 volts. When it made its way over to 70E, it became 240 volts or less. But there's a lot of question and debate right now, even within IEEE, what is a reasonable low-limit cutoff right now. And this is something that's been discussed, and I'm actually heading up a task group within IEEE to discuss and come up with maybe a different method. And I'm going to talk about that towards the end of our discussion here. The 130.5, beginning in 2012, what NFPA has done is they've simply deleted the exception. And you may think, well, okay, but now what? Well, what they're doing is in its place, they're saying that, well, you still may be able to exclude certain low voltage, low current systems from the study, but what they do is they just refer to or default to IEEE 1584. So as we learn more and things change, the IEEE 1584 will reflect the direction to take all this. I say to be continued because we are going to be talking a little bit more about this coming down the road. Another big change within NFPA 70E is that of the 4-foot rule. The 4-foot rule in the past has been a simplified approach to define the arc flash boundary. And beginning with the 2012 edition, the 4-foot rule is going to go away. In fact, in 2004, the 4-foot rule was applicable if you have a short circuit current and clearing time up to 300 kiloamp cycles. And then with the 2009 edition, that was reduced. You could still use the 4-foot rule up to 100,000 amp cycles. And then 2012, it's gone. So you may be thinking, well, it's gone. What do we do? Well, there are going to be more specific arc flash boundaries that are going to become part of the hazard risk tables, and we're going to take a look at those here shortly. Some other changes. The arc flash boundary, this was back in the 2009 edition. There were a couple of ways to go about this. For systems up through 600 volts, between 50 and 600 volts, we had the 4-foot rule, which is going away. Otherwise, you calculate the arc flash boundary based on at what distance does the energy drop to 1.2 calories per square centimeter. That's the threshold of the second-degree burn. For voltages above 600 volts, 1.2 calories was used unless the clearing time is less than a tenth of a second. And in that case, you were permitted to define the boundary as 1.5 calories per square centimeter. Well, beginning with the 2012 edition of NFPA 70E, the arc flash boundary is going to be the distance where you reach 1.2 calories per square centimeter, period, unless you use the hazard risk tables. And then there will be boundaries that are included within the different hazard risk tables. Equipment labeling, this is another area that receives a lot of attention. And there were some pretty significant changes when it comes to labeling for the 2012 edition. In 2012, there is going to be language that's similar to what you find in the National Electrical Code about what equipment is to be labeled. And it's electrical equipment such as switchboards, panel boards, industrial control panels, very similar to what you find in the National Electrical Code. It's not inclusive. It says equipment such as. And the other part of this is it's equipment that's likely to require examination, adjustment, servicing, or maintenance. So they're being more specific about the equipment that is to be labeled. The question is now, okay, what goes on the label? And beginning in 2012, what goes on the label, the requirements, you either have the available incident energy, which would most likely be derived from calculations, or the minimum arc rating of the clothing. So if you choose to use, for example, like 8-calorie or 12-calorie protection, that would go on the label, as well as the date of the arc flash study, the nominal voltage, system voltage, as well as the arc flash boundary. So there are increased requirements of the data, the information that's going to go on the label. And right now, there are a lot of different ways to produce a label. In fact, there's going to be a new annex in the back of NFPA 70E that's going to give some of the labeling options. And a lot of the software produces labels such as what I have on the screen. And not all of this is required, and some choose to use it all, some choose not to. Item number 1, that meets the requirement of the National Electrical Code where you have a warning label. Item number 2, this is the arc flash protection boundary, which is going to be relabeled arc flash boundary. Number 3, this would be the calculated incident energy. Some still put the PPE level. You're prohibited from having the HRC, the hazard risk category. Some still use levels, some don't, but you're going to have at least the calculated incident energy or the arc rating. A few will actually list the PPE. More and more people are getting away from that since the list tends to evolve. And then some will also include the shock boundaries, the voltage, the limited approach boundary, the restricted approach boundary, prohibited approach boundary. The date is to be a new requirement. And then some will also list what equipment this is being fed from, as well as who performed the study and the file, the computer file for the study. Hearing protection, it's been included in the past in NFPA 70E, but it was really just listed in the tables of what PPE to wear. So beginning in 2012, hearing protection, they're going to be more specific about hearing protection, and it's to be worn when you are within the arc flash protection boundary. And hearing protection, my view, is quite important. When I've been in the lab, even low-level incident energy, shots of like 1 to 2 calories a square centimeter, to me, it sounds like somebody has a gun off going next to your head. And it's quite loud. And if you're involved in more explosive arc flash, well, it can cause some serious and permanent hearing damage. The hazard risk categories, the footnotes that were in the bottom of the hazard risk categories, used to have limits, maximum short circuit current, maximum clearing time, and these footnotes are actually going to be embedded and be part of the tables, which I think is a great idea, because then you'll be able to look at your equipment, look at the task, and the limitations are right there. And the reason you have limitations, what I have on the screen is a time current curve of an adjustable molded case breaker. And the upper part that I have circled, that's for overload protection for low-level currents. And then down towards the bottom, this is the instantaneous, fast-acting, fast operation. We have some adjustable devices have low settings, as well as higher settings, as well as many settings in between. And the magnitude of short circuit current and the protective device has a lot to do with the incident energy that you can have. And this is why these footnotes are so important. For example, if you have, I have a little red line out towards the right, a really high magnitude short circuit current, well, the setting isn't going to matter as much. Whether you have a low setting or a high setting on the left, that's a time scale. This protective device should trip incredibly fast. But the problem is if you have a lower magnitude short circuit current, well, then the device setting is going to matter. If you have, for example, the higher setting, and you have a short circuit where I show the vertical red line, the short circuit current misses the trip characteristic of the higher setting. And in theory, this device could time out a very long time. Now, would it really time out that long? I don't know. I kind of doubt it. Bus bars burn up. Sometimes arcs extinguish, but you have no way of knowing. There is something known as the 2-second rule from IEEE, where depending on whether or not you have sufficient room to escape and other factors, you may be able to cut this off at 2 seconds, assuming that someone has jumped out of the way or, I guess, worst case, blown out of the way. The hazard risk category boundaries, or excuse me, the hazard risk protection boundaries, these are going to be included in the tables. Back in 2009, these are the 2009 tables that I have up right now. You would look up the equipment, you would look up the task, and then you would have to know to follow the limitations of the footnotes. Well, beginning with 2012, a lot of the good information from the footnotes is going to be included into the tables. So we're going to have the upper limits of short circuit current and the upper limits of clearing time included in this column, and then we're also going to have the arc flash boundaries included. So you're going to see some of the good information being directly part of the table, and that eliminates some of the confusion of referring to the footnotes, as well as, well, some people didn't know to refer to the footnotes. And so then you could look up your equipment and your task, and all the information is there for you. With DC is now being included in the 2012 edition of 70E, and for DC arc flash, we have hazard risk categories for DC as well, and these kind of parallel what we have with the AC tables. With the DC tables, you'll be looking up your voltage, and you'll be looking up the short circuit current, which is also in the table, and then you have a hazard risk category and all the other associated information that goes with this. So this is going to be a great step, because I know from my own experience, I get the question a lot, what are we going to do about DC arc flash? And so having this in the NFPA 70E, the 2012 edition, is going to be a great leap forward, and this whole thing is greatly appreciated by everybody in the industry. Category 2 star, this is another area that's caused some confusion, because I know many people recognize that sometimes the term category is equated to 8 calorie per square centimeter, and then you see 2 star and you scratch your head and think, well, where does that fit in? And 2 star is actually just a function of the hazard risk category tables. Well, beginning with the 2012 edition, the star is going away. All you're going to see is category 2. And the new requirement, Category 2, is now going to require the balaclava sock or an arc flash suit hood. So 2 star goes away. Category 2 is now going to require the balaclava sock, basically protection for the back of the head, because there were other parts of the code of 70E that would say you need to protect all parts of the body in the arc flash protection boundary, but that didn't always happen. The case where you have a calculated incident energy, 12 calories, you're going to be required to wear an arc flash suit hood. So if you have energies greater than 12 calories, you have to wear the arc flash suit hood. That's a new requirement for 2012. And for face protection, the requirement's going to be enhanced, requiring face shields with a wraparound guarding to protect the face, the chin, the forehead, ears, neck, and that's going to be a requirement. We have a birthday party coming up. And for the birthday party, you might be thinking, what does this have to do with what we're talking about? Well, in a couple of months, IEEE 1584 is turning 9 years old. And since that time, when IEEE 1584 first came out, the IEEE Guide for Performing Arc Flash Hazard Calculations, We have learned a lot. When this guide came out, it was one of the most amazing documents, just my opinion, that I have seen in a long time, because it covered and answered a lot of things that, well, we didn't have an answer before. And this was based on over 300 tests, and it provided the equations that we still use today, for arc flash studies. And since the 1584 standard first came out, we have learned a lot. A lot of new things have happened. And some of the things that we have learned and that we're still working on, the 208-volt 125 kVA transformer exception. I'm going to talk about that in a little more detail. Arc sustainability, that's an issue that we recognize is a significant issue, but that's one that is still being investigated. DC arc flash, we're seeing some movement with DC arc flash within NFPA 70E. I'm going to talk a little bit more about this here in a few moments. And a new standard that's going to be coming out sometime down the road. It's called IEEE 1584.1, or a guide, I should say. IEEE 1584.1. I'm going to talk about this one as well. But I want to start by talking about the 125 kVA transformer exception. IEEE 1584 had some language that equipment below 240 volts doesn't need to be considered as part of the study, and below 125 kVA transformer. 125 kVA, that was actually implying like a 112.5 kVA transformer, and below 240 was implying 240 volts. And part of the reasoning behind this was when you have an arc flash at lower voltage, at lower current, it's not always easy to get it to sustain. And so the transformer was originally used, transformer size, because if you have a short circuit on the secondary side of larger transformers, well, you have more current, more intense, as I called it earlier. And if you have a short circuit on, let's say, the secondary side of a smaller transformer, well, the short circuit current tends to be lower. And the way the IEEE equations are configured right now is if you have a low short circuit current and your upstream protective device, which is sometimes the transformer primary, it may not respond fast enough. So you have a low current with a long clearing time, and you can end up with some, some pretty large values. Well, some of the research, and some of this was done back with the original 1584 tests, it depends on a lot of things as to whether or not you can actually even sustain a low current, low voltage arc flash. It depends on, for example, the size of the enclosure. You can sustain a lot easier in smaller enclosures. It depends on the orientation of the bus. It depends on the insulation. It depends on whether you're terminating into barriers or not. And I ran through a few example calculations, just looking at short circuit currents from transformer size and from duration. A 112.5 kVA transformer with a one cycle duration, you have a very, very minimal amount of calculated incident energy. You need to go up to 6 cycles before you get into the 1.2 calorie. The 75 kVA, it drops. It goes down. Lower, smaller transformer, less short circuit current. 45 kVA transformer, it becomes even lower. So the big issue right now, and these are things that are being investigated, is what does it take to sustain an arc flash? Do they self-extinguish? And the answer is not there yet, but there's a lot of really good work that's going into it. This is from some testing that I was involved in last year. We were actually taking a look at low voltage, low current arc flash using actual equipment last year. And you look at the result up here on the line side, and it looks like, well, the trigger wire melted and not much else. But then you go down to the load side, and we lost quite a bit of bus. So when you think you're safe, well, sometimes the information points you in maybe a direction that you hadn't planned. Where I believe this is going, and this is not coming from any official type of a source, but the 125 kVA transformer exception, I'm actually heading that task group up. It's most likely, when it is revised, going to be more of a short circuit current rather than a kVA, because then short circuit current, that's easily applied. And we've even been talking about maybe having a default energy. This is just all, table discussion, because one of the problems you have with the exception, if you have a circuit that's exempt, then you throw your hands up in the air and say, okay, what does that mean? What do I do here? And that question was never answered. So hopefully that question will be answered. Another question area is the 40 calorie per square centimeter limit. This is referenced frequently, and in fact I just had an article out in Electrical Contractor magazine about 40 calories. And more investigation needs to happen, because the problem with the 40 calorie limit, if you have a large magnitude short circuit current over a short duration, yeah, that's going to be explosive. But the way the calculations, the equations are structured, you can also be above 40 calories if you have a very limited amount of short circuit current but a long clearing time. That one most likely is not explosive. So this is another area where good investigation and research is ongoing, and we'll see where this takes us in the future. DC arc flash calculations are going to be the next big thing, and there have been a lot of really good papers presented. Some of them are referenced in the 2012 edition of NFPA 70E, and sources of DC current, they are everywhere. And the basics of DC arc flash calculations, I actually talk about this in one of my training programs, but the basics is you have a circuit, and you look at the information of your source resistance and your conductor resistance, and those can be obtained. But the missing link is you also add the arc resistance. And the question is, well, where does that come from? Well, there's a series of equations that you can use and use an iterative solution. And once you know what the arc resistance is, then you can revert back to some of the basic power equations. You know the arcing current, you can calculate that. Once you know the arcing current, I squared R, that's the power in the arc. And once you know the power in the arc, factor in time. That gives you the energy in the arc. And then there are a series of equations for the arc flash in air, spherical equations, and arc flash in a box. And so there was a paper presented about a year and a half ago that was an extremely good paper that gave us some forward movement on DC arc flash calculations. I mentioned IEEE 1584.1. This is a guide for specifying arc flash hazard calculation studies. This is something that myself and a good friend of mine and colleague actually wrote. We were heading up a meeting, this was several years ago, in Dallas, and at the end of the meeting we realized we need to just sit down and write the draft of this ourselves. So it was at the Hyatt in Dallas, and we walked out of the meeting into the atrium, which is where they had the lounge, otherwise known as the bar. So it was 10 o'clock in the morning, 2 big cups of coffee. We proceeded to spend the entire day writing the first draft of IEEE 1584.1 in the lounge, in the hotel in Dallas. So the story goes, when you see this come out, 2 guys walk into a bar in Dallas, and IEEE 1584.1 was born. So what's next? And that's the big question. The arc flash, what we know about it, it's evolving, it's changing, it's getting better. We're learning more. There are many, many people out there that are taking an active role in trying to make things safer. People involved in the research, people involved with the manufacture of equipment. And in fact, the electrical equipment manufacturers, they've all been aggressively trying to address electrical safety with the design, with innovations in their equipment. And I actually have Allan Worthy from Siemens here in Bethesda with me. And I'd like to actually ask you, Allan, what do you see as a few of the major advances with equipment?
Good afternoon. This is Allan Worthy. As John said at the beginning of the presentation, I've got product management responsibility for low voltage switchgear and switchboards. So my comments are going to be based on the perspective of low voltage, because that's that's the product that I manage, and that's the majority of my experience. But it's really also going to be covering as best I can, medium voltage applications also. From a manufacturer standpoint and from an apparatus standpoint, basically the solutions that Siemens and most manufacturers, if not all manufacturers, offer can be really grouped into 4 different categories. One is solutions that we offer that will reduce the chance or the likelihood of an arc fault, arc flash occurring. Examples of that would be insulated bus, shutters, breaker shutters, barriers, things that keep exposed bus away from personnel as they're doing maintenance or doing other work. The second category would be removing personnel from the arc flash boundary. Examples of that would be remote racking, remote operation, open and closing of the breaker, those types of operations. The third category would be reducing arc flash incident energy. That's where basically you're reducing the incident energy primarily by reducing the arcing duration. The three drivers of the incident energy, the three major drivers, is going to be the available fault current, the voltage, and the arcing duration. And we as a manufacturer really have more control. The things we can do to reduce the arcing duration is what we mainly focus on or have focused on to date. The fourth category is incident energy containment. And that's where basically an example of that would be arc-resistant switchgear. So if you look over the recent, or you look at arc flash and recent advancements, the ones that come to mind for me would be the ability to temporarily lower the parameter settings for either a breaker or a protective relay, so that when personnel are working on equipment, you can have those alternate parameter settings such that the breaker or the relay is going to detect a fault and clear that fault quicker. You basically want to have your pickup setting. Typically, it's going to be reducing the instantaneous. That typically gets you the biggest bang for the buck. So when someone's in the the electrical equipment room doing maintenance, working on the equipment, you activate that what's called maintenance mode, where you're going to temporarily reduce, say, the instantaneous pickup. You want it to be as low as you can possibly go, so that it will be below the arcing current level. But you also have to look and make sure that you don't get nuisance tripping. So there's always that compromise. But the faster the breaker or the protective device can trip, the lower the incident energy rating. So that's something that has been developed recently. There were some other solutions that have been around a long time that really weren't developed specifically for arc flash, like zone selective interlock, differential relaying, those type of things. But the ability, the maintenance mode, has really been the thing that's been developed primarily looking at arc flash hazard and trying to reduce that. Also, you've got arc-resistant electrical distribution equipment. Today, the IEEE standard, or IEEE guideline actually, C37 20.7 covers medium voltage and low voltage equipment. So there is a standard, or there is a guideline that tells you how to test your equipment to guarantee, to certify that it is arc resistant and it is able to safely contain and distribute the arc fault, the gases, the pressure, everything away from the operator. So that's something, at least from low voltage switchgear and medium voltage switchgear, that's been a big improvement. Also recently, there's been a lot of focus on enhancing the ways or adding to ways that you can remotely operate your electrical distribution equipment. Examples would be opening, closing of breakers, which have been around for a while, but now all manufacturers have ability to, you can remotely rack breakers, you can remotely activate that maintenance mode. So there's been a lot of focus on remote operation and control of the electrical distribution equipment to get the operators out of the zone. So I would say, those two, the ability for the maintenance mode and the arc resistant would be the recent enhancements that's been the most popular.
I have another question for you, Allan. What new ideas or new innovations, give us kind of a sneak peek here, do you see coming down the road or on the horizon?
A few things there I guess I could make comment on would be that there has been a decision made by IEEE with the C37 20.7 working group. That guideline covers arc-resistant switchgear at this time. There's been a decision made that there's working groups have been established, a chair and members have been decided, and it's been decided that the scope of that guideline will be expanded so that it will include additional apparatus. And that apparatus has been identified, and it's going to include medium voltage motor control centers, low voltage motor control centers, switchboards, and busway. So there is an effort. Like I said, the working members and the chair has been identified, and they expect to be able to create the draft version, get it voted upon, and get it released over the next 2 years, so that at the end of that period, the majority of electrical distribution equipment, there will be a guideline that tells you how to test that equipment so that you can certify it as being arc resistant. So it's going to greatly enhance or expand the scope of arc resistant equipment offerings. There's also the development on a new UL standard. Right now it's just an outline of investigation. It's a UL 2748 that has been, the draft version has been released. The title of that outline of investigation, which hopefully or probably will become a standard at a point in time in the future, is called arc mitigating equipment, arcing fault mitigation equipment. So it will include all the systems that are, identified as being able to mitigate arc faults, and the standard is out today. The outline of investigation at least has been released, and it's available for you to view and see what has been covered and what is included in that outline of investigation. I think it's still definitely a work in progress. It's going to take probably a couple of years to really expand the scope and include what I think will eventually be included. But it is in progress, and it will be established. The third thing, I think the enhancement of the smart gear capabilities, that remote operation and control that I talked about, is really going to be enhanced. I know Siemens is looking at a lot of different ways that we can, we're working on what we call smart gear from a medium voltage, low voltage standpoint, where you can remotely monitor, control, and configure your electrical distribution equipment. We also plan to include preventative and predictive maintenance, being able to monitor temperature on the bus bar inside the breaker, all different environmental conditions there also.
And then the final question I have for you, what do you see as right now the best or the most popular solution so far?
To date, I would say, especially if I look at low voltage switchgear, which I'm most familiar with, the majority of the specs that we see on low voltage switchgear either specify or request as an alternate the alternate parameter settings, the maintenance mode on the breakers. That has become very widespread and very common. Also, the number of specifications and number of requests for arc-resistant switchgear is really starting to increase. C37 20.7 was released in January 2007, and at that time, since that time, then the majority of quotes, I would say, not the majority, but the percentage of quotes that we've received has increased from 0 at the beginning. An occasional company who was familiar with the standard was asking for it, to now probably 30 to 40% of all the inquiries we receive are asking for either having arc resistant or quoting that as an option to the standard quote that they've requested.
Thanks, Allan. Where we're going next, there's been an IEEE NFPA collaboration for arc flash testing and arc flash research, and this is where a lot of our next generation of information is going to come from. And this is a global collaboration. There are two main representatives from Europe, from Germany, and from the United Kingdom. We have one representative on this collaborative group from North America, the U.S., one from Asia, in particular China, and also one from Australia. I'd like to give special thanks to Electrical Contractor Magazine and to Siemens, our sponsor for this webinar. And while we've been online here, we've received quite a few questions, and I have a little bit of time left. I'd like to see if we may be able to address a few of these questions. The first question, actually a pretty good one, well, they're all good, was about the requirement for the arc suit hood, the 12 calorie per square centimeter. You're actually starting to see 12 calories show up quite a bit in NFPA 70E. And the question is about printing labels, because 12 calories doesn't correspond to one of the categories that people use. And this person is in the process of printing labels. Well, I have to qualify this with, this is not an official response from, I don't represent NFPA, I don't represent IEEE. So with that, one of the things that NFPA has been doing in recent years is trying to separate arc flash calculations from categories. And this is one of the potential problems, that if you try to categorize the calculated incident energy, it's going to start to have a collision when you try to align it with some type of level or category. So in this case, with the 2012 edition of NFPA 70E, the requirement for labeling is, and it says pick one. You have either the calculated incident energy or the arc rating. And so what I see is more and more people are going the arc rating route for their labeling. So for example, they will decide that they're going to use 8-calorie or 12-calorie protection for what the industry refers to as their daily wear, and that goes on the label. And so then you have to make sure that all of your calculated incident energy is less than what you have on the label. It's very similar to the approach that we take with short-circuit studies. Those of you that have been involved in short-circuit studies, it's very analogous, that you calculate a maximum short-circuit current, you compare it to a protective devices interrupting rating, and on the equipment, on the breakers, on the fuses, on the panels, you have the listed interrupting rating. And so it's kind of following that path. You have the minimum arc rating required, and then make sure that your calculated incident energy falls below that. So the actual question about correlating it to a category, that's going to be a tough one and not really achievable. And NFPA 70E, the 2012 edition, is steering, well, 29 began to steer away from it. In 2012, it's specific. It's calculated incident energy or the arc rating. So, you know, put 12-calorie arc ratings on your labels and leave the categories out of it would be the best approach. There's another question about arc flash analysis. Are these going to be required for all new and modifications and upgrades? And actually, the arc flash hazard analysis, NFPA 70E, the interpretation that I believe everybody, well, not everybody, but many are familiar with is this is safety, and safety is, you know, now. So there's a requirement that the arc flash hazard analysis applies to everything that's listed within Article 90 in NFPA 70E. Now, how you go about it, there are two different methods. You can go through the full-blown calculations, the incident energy analysis, or use the hazard risk tables as another method. Well, here's a good question. Is it possible to get a copy of the PowerPoint? Well, not the PowerPoint exactly, but this presentation, the video, will be on Electrical Contractor Magazine's website, and that is ecmag.com. So you'll be able to, I'm not sure when it's going to be uploaded, but you'll be able to obtain it from there as well. Another good question, and I've actually had this one a lot. If we have existing arc flash labels, will we be required to replace the labels? I have a forum website. It's called the arcflashforum.com, and every week there's a new question that gets posted out there, and this one was just posted recently. And many of the people posted that they already have labels that they consider compliant. They've gone with all the detailed information. But if you don't have all the detailed information, that's going to be a decision that someone is going to have to make. The NFPA 70E says that the arc flash hazard study has to be reviewed periodically, not to exceed 5 years. And, well, the information from that study goes on the labels. I am going to turn this over to John Maisel to wrap things up for it, and I greatly appreciate everybody joining in. I appreciate being here with John and with Allan. And John?
Thanks, Jim. And again, we just thank both you and Allan for this most informative hour on an area that is critical to virtually everyone who has any connection with the electrical contracting industry. So we appreciate it. And again, we want to express our special thanks to Siemens Industry for their support in enabling us really to share this information and hopefully educate our audience even further on this vital subject. So thank you all around. I do have one note, Jim. You had mentioned the full transcript, including slides of this presentation, will be available on our website, ecmag.com, within 48 hours. It will then be up on our site through that link. You can reach it through our homepage at that site, and it will be linked. If you haven't registered, you're not here. But if you have any of your coworkers, peers, or any others who might be interested in reviewing all of this or hearing it, please have them go to our homepage, go through the link and register, and they will have full access to the proceedings. Following approximately 90 days that it will remain on our website with registration, we will be linking and posting to our website. So it will be archived in its entirety after 90 days for a good 6 months, or I'm not sure about 3 years, but it will be up on our website. Once again, thank you all so much for your attention. I know everybody out there is busy, but this is good stuff, and it's important to our industry. So on behalf of Electrical Contractor Magazine, on behalf of NECA, on behalf of Jim and Allan, Siemens Industries, thank you all so very much, and we look forward to signing up for other webinars on topical areas of interest. So keep checking, and we'll be in touch with you all. Thanks once again.